Hey there, and welcome back to How'd You Get That? Today we are tackling a problem involving reciprocal trigonometric functions. We're going to be using cosecant today, but this tactic works with other reciprocal functions as well. So let's just jump right into it. The question is this: find the intersection point or points of these two functions. F of x is equal to 3/2 cosecant x minus 1, and g of x is equal to 2 sine of x plus 1. So as we do when we normally want to find the intersection point of any two functions, we set the functions equal to each other. So we get this relationship. Now the strategy for solving many of these trigonometric function problems is to get all of the trigonometric functions into a single trigonometric function. So often we want to get that into, say, sine or cosine, which are nice and simple trig functions. So for instance, cosecant can be rewritten as 1 over the sine of x. And I'm going to leave sine of x just by itself. Now I'm going to do a little bit of algebraic manipulation to get everything in terms of sine of x. So for instance, I can add 1 to both sides and then multiply by 2/3, and then I can multiply both sides by the sine of x. If I distribute sine of x, then I get this formulation on the right-hand side. All that is equal to 1. And that's okay that we have a sine squared term now. That's actually what we want. Now I'm going to subtract 1 from both sides to set everything equal to 0. Now take a look at this. If I were to replace the sine of x with a letter, say p, I would get this relationship. 0 is equal to 4/3 p squared plus 4/3 p minus 1. And that's just a quadratic, which we know how to solve. Now, as we're solving this, I'm going to leave sine of x in there instead of p, but if it makes you feel more comfortable to leave p in there and then make the substitution at the end back into sine of x, then that's totally fine. Totally do that. But here, we're gonna be working with sine of x. So now, I have 0 is equal to 4/3 sine x squared plus 4/3 sine x minus 1. Now, I'm going to multiply through by 3 here to clear the fraction, so I get 0 is equal to 4 sine squared x plus 4 sine x minus 3. Now I can solve this using my normal factoring. We can also use the quadratic formula here so that sine of x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But in this case, this one is actually factorable, so let's try that. So I can factor this into two factors. Something times the sine of x plus or minus something else times something times the sine of x plus or minus something else. The second blank in each of these parentheses must be 1 and 3. That must be true because 1 and 3 are the only factors of 3, so they must multiply to 3. Furthermore, whichever one is positive, the other one must be negative because they need to multiply to -3. So I'm going to write that as sine plus or minus 1 times blank sine minus plus 3. So we need to figure out what these other two blanks are, the coefficients in front of each of the sine terms. Now these blanks need to multiply to 4 because that's the leading coefficient in our quadratic here. So those factors could either be 2 and 2 or 1 and 4. We can try to make an educated guess here, but essentially we would have these 6 different ways of combining things depending on whether we used 4 and 1 or 2 and 2, along with -3 and 1 or -1 and 3. And this list here outlines what our middle term would be. But only one of these possibilities gives the middle term of 4 times the sine of x. That possibility is -2 sine of x plus 6 sine of x. Added together, those equal 4 sine of x. That corresponds to -1 being multiplied by 2 and 3 positive being multiplied by 2 as well. So the leading coefficient in each of these factors must be 2. Furthermore, we'd want a -1 and we want a +3. So ultimately we get this factorization. 0 is equal to 2 sine of x minus 1 times 2 sine of x plus 3. Now we can separate this into two different equations. So 2 times the sine of x is equal to 1, or sine of x is equal to 1/2, and 2 sine of x is equal to -3, or sine of x is equal to -3/2. Let's take a look at the second one first here. So sine of -3/2 is, well, let's think about that. -3/2 is actually less than -1, but the sign of x must be between -1 and 1. So there actually is no solution to this second factor here. Okay, so if we now take a look at our first solution, sine of x is equal to 1/2, that remains our only possible solution for this problem. So sine of x is equal to 1/2. What angle has a sine of 1/2? Well, that would be, in the first quadrant here, pi over 6, or 30 degrees. Now, there is another solution here in the second quadrant, which would be pi minus pi over 6, or 5 pi over 6. So these are our two solutions in the interval 0 to 2 pi, or 1 full unit circle, that have a sine of 1/2. Pi over 6 and 5 pi over 6. So ultimately, our solution to this whole problem is 5 pi over 6 and pi over 6. Plugging that x value into either of our initial functions, f or g, we get an output for both of those of 2. So therefore, these two functions intersect at the 2 points pi over 6, 2 and 5 pi over 6, 2. If you have any questions, leave them in the comments below, along with any suggestions you might have for future episodes of How'd You Get That? Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see you in the next problem.